All right, after 2.1, I know you guys probably need a break, so 2.2 should be quick and fast. So in the last section in the beginning of 2.1, let me just highlight some things real quick. And the beginning of 2.1, I know you're probably scared of coming back here, but in the beginning, we talked about the domain of a function. It's loading. Okay. So remember, we define a domain of a function being that for every single x value, there's exactly one corresponding y value. So I gave you that birthday example. And we saw how to look at functions when it's given in this relation form or even in equation form. But the question is, how does this definition apply to graphs? And that's what 2.2 is about. So how do you know something's a function? Is by looking at the graph. And the rule is that we use the vertical line test to determine whether a graph is a function. So the vertical line test states this: a set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph in at most one point. At most one point. Okay, so what you're doing is you're basically taking a vertical line. I'm going to use a ruler here, right? So here's my vertical line, right? And you're going to pretend that it's going through the graph very slow like this, right? And as you move through the graph, you're looking at how many times this vertical line will touch the graph. See how it's touching the graph at this one point here. And then as I move it, it touches here, right? But it's only intersecting this first graph only one time every single time I'm scanning through this, right? And so that means, okay, if it's only intersecting the graph at one point, this thing is a function. So this guy is, yes, this guy is a function. Now, of course, it says in either case, whether it's a function or not, you need to give the domain and then give the range, okay? So now you want to be able to give the domain and range by looking at the graph, right? So remember, the domain was all the inputs, right? So basically, the domain is all the x values that you're substituting in, and the range is going to be all the y values that are a result of plugging in those x's. Okay, so here's how I want you to think about finding the domain. So domain is something is in the domain, like we talked about in the last section, if you plug in a value for x and you can find a y value, right? So here is my analogy to find the domain. So you're going to start at negative infinity, and you're going to be walking, you're this little person, and you're going to be walking on this x-axis that's supposed to be right here. It's just hard to see, right? And the whole time, you're going to be either looking up or looking down. If you're standing on a particular x and you look up and you see the graph, that means that x that you're standing on is in the domain, right? Now this thing goes up forever. So technically, as you're walking through here, your eye should be looking up the whole time, and you can see parts of the graph. Can you see at -3? Yep, I can see it here, I can see it here, I can see it here. Technically, right here, you'd be standing on the graph, and then the whole time, as you go from negative infinity to infinity, you can find for every single x value that you're standing on, you can see the graph, right? So your domain is actually negative infinity to infinity in this case. Now the range, right? So that was the domain. That's my analogy for the domain. Domain stands for all the x values. So you're a little person walking on the x-axis, okay? So now what about range? Now you're going to get a little lazy. Now, typically, you would see an x, y curve like this. You're going to be taking an elevator, sitting in this elevator like this. I really need to get better at drawing here. Okay, here's your elevator, right? And you're going to be taking this elevator upwards, okay? But now you're wondering whether or not a y value, you can see y values. So instead of looking up and down, you're going to be looking left and right. So if you start at negative infinity, right, you wouldn't see any, if you're sitting here on your elevator, you wouldn't be able to see any part of the graph if you look left or right. So the first time that you actually see as you move upwards along, you're taking this elevator on the y-axis, by the way, the first time you would see the graph is actually at level 0, right? You'd be right on the graph. So actually your range is going to start at 0, but as this elevator moves upwards, right, you can look left and right and still see the graph, right? And the whole idea is, can you see it, right? And you can see it the entire time as you travel up this elevator all the way to infinity. I know it's a super lame thing, But trust me, it's one of the easiest ways to describe how to see it from a graph. And then, whenever we're back on campus, I usually hear people like, okay, take an elevator upwards. And then it's just an easy way to describe it. Okay, same thing's going to happen here. So let's start off with whether or not this guy is a function. So here we go. We have our vertical line. And I'm just using this side of my ruler to pretend that see whether or not this vertical line is touching the graph more than once. So as I scan, nope, just hitting once every single time. So if it only hits once every single time, we know that this is a function. Okay, and then now we want to find the domain. So here I go again. I'm walking on the x-axis. I'm looking up, I'm looking down to see whether or not I can see the graph. Now the hard part of this is obviously this curve. You see this arrow down here, and as you move down, bless me, thank you. So as this guy moves down, it's actually going wider and wider and wider. So actually at negative infinity, you would be able to see it by looking down. So as you take your little stroll, you'll be basically looking down the whole time, looking down. At 0, you'll be standing on it, so you could still see it. And then as you continue your journey to the right, you would see it the entire time. So again, your domain is negative infinity to infinity. Your range, okay? Now your range is going to go, again, now you're on the elevator status, right? You're down at negative infinity. And actually, down at negative infinity, if you look to your left, you could see it. So as you travel up, you can actually see it's on your left, it's on your left, it's on your left. And then at 0, you're touching it. And then as you pass 0, you can still see it, but now it's switched. It's on your right-hand side. So as you travel from negative infinity to infinity, you can see the graph. So again, your range is negative infinity to infinity. All right, so that's the first example. Well, we have 2 more to go through. Notice that in both these cases, right, if you draw a vertical line, bam, right, here's a vertical line right here. It touches the graph in 2 different spots, right? So it fails, both of these fail the vertical line test. Right now I can get rid of my ruler real quick. So why does the vertical line test really even defy or go against or contradict the definition of a function? So let's talk about that real fast. So remember, the definition of a function was that for every single x, there exists only one y value. So that's why the vertical line test works for graphs, to tell whether or not it's a function, because, like, for instance, here's an x value here. Let's say this is like just below 2, right? Let's just say 1.5. If I plug in 1.5, I'm getting this y value here in red and this y value in red, right? Same thing is happening here. When I plug in 1, I'm getting this y value and that y value. So this one x value is corresponding to 2 different y values. That's a no-no for functions, right? So that's why the vertical line is testing whether or not a graph is a function. It's testing to see, for every x, is there exactly one y value. Okay, so now for domain, right? It says you have to find it either way. So domain, range, I'm going to shorthand this to do DNR now. So for your domain of this guy, right? Again, you're still walking on the x-axis, but notice that if you start at your walk at negative infinity way over here, you won't see the graph at all by looking up or down. So the first time you actually see the graph is at 0, because you'd be standing on it. And so you see it here. So notice that I use this bracket symbol to mean I can see it at 0. And then as I continue my walk from 0, I can look up or down and see the graph. So it actually goes from from 0 to infinity. And now the range. Now the range for this one looks difficult, but now you're on the escalator. But this is supposed to get wider and wider and wider and wider. So actually, when you're standing at negative infinity, you'd be able to see it. And as you travel upwards, you should be able to see it the entire time. So your range should be from negative infinity to infinity. And now for the last one. The domain of this guy is you're traveling on this x-axis, right? We already know it's not a function. The first time you would see it is at this point right here, which is -3. So I'm saying -3 included. And then I would see the graph. I'm looking up and down, looking up and down, looking up and down. And the last time I would see it is when I'm at 3 itself. And since I can see it at 3, again, I use that bracket to say I can see it at that number 3. And now, if you were to guess the range, hopefully we can get this. The range is also going to be from -3 to 3 because as I'm traveling up that escalator, that elevator, you can see it at -3 here and to here. But after you pass level 3, right, I always think of these as levels, right, -3, -2, I can see it at all those levels, but I just cannot see it past 3 or below -3. So that's my domain and range for those problems. Okay, so hopefully that helped. That was just a quick intro to what we talked about in 2.1, and now we're just looking at the graphs and being able to determine whether or not a graph is a function. Okay, so some more notation, and I've kind of talked about this in the last section too. So remember I told you when I give you this notation, f of 1 is equal to 5, I want you to understand that means that this point 1, 5 is a point on the actual curve, and that's what this part is basically illustrating here. So if x, y is a point on the graph of a function f, then y is the value of f at x. So meaning all that's just saying is that y is equal to f of x. So if that happens, then x, y is a point on the graph of f of x. For example, if 1, 9 is on the graph, the notation you're going to see now is that if you plugged in 1 and you got 9 for the y value. So again, I'm just like I talked about before, this notation is relating back to this notation. Meaning if you have f of 5 is equal to 4, then there's the point you plugged in 5 for the x and your outcome was 4 for the y value. Okay, so now knowing all that, we want to be able to look at the graph and be able to answer these several questions. So example number 2, part A. What are f of 0, f of 3 pi over 2, and f of 3 pi? So let's start with f of 0. All they're asking me to do is look at the graph. What happens when I plug in 0 for my x term? So again, if I plug f of 0 in, here's my x of 0, my y value is 4. So I'm just locating that value right there. Okay, keep doing this. F of 3 pi over 2. When I plug in 3 pi over 2 for x, my y value is 0. When I plug in f of 3 pi in, 3 pi, my y value is -4. Okay, so again, this is saying when I plug in x equals 0, what's my y value? When I plug in x equals 3 pi over 2, what's my y value, right? If I plug in f equals 3 pi, what's my y value? What's my y value, right? And so I just look at the graph and I circled all those things from there. So the next question is, what is the domain? Now, of the picture that we have here, the domain is talking about all the x values that we can substitute in. Now, again, obviously the graph is then given to us from -infinity. So the first time we can see the graph is when we're standing on 0, we can look up and we can see the graph. So we can see it from 0, and we can see it the entire time we're walking all the way till we get to this value right here. If we want to know what that value is, look up. The x value right here was 4 pi, so we can see it from 0 to 4 pi. Right, now I know you guys can obviously see that this is the cosine curve, right? But we're only giving, they ended it on purpose, right? That's why they're asking you the domain in this question. Now, what's the range? Now, here we go again. Let me erase these colors right here. So I'm going to pause real fast as you copy that down. Okay, so let me erase this. Okay, so what's the range of f? So again, we're taking our elevator, and at -infinity, I can't see anything. The first level I can actually see the graph is when I'm sitting in my elevator at level -4. So I can see at -4, and I actually can see it the entire time until I get to level 4, and that's the last time I can see it, because after I pass that, I won't see it anymore. So my range is from -4 to 4. And now it says list the intercepts. Okay, so after looking at some of your homework questions, sometimes they want a list separated with commas. I'm sure you guys caught on to that already. So for x-intercepts, I stress so much that I wanted you guys to write it as points, but it seems like your homework isn't doing that. So for x-intercepts, just start listing all the x-intercepts, which would be pi over 2, and I think your book wants you to, your homework wants you to list it like this: pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. The y-intercepts would just be one of them at y equals 4. Okay, now I would normally want you to write these in points, but after looking at some of your guys' homework and the questions you've been asking me from last week, it seems that you're going to want to write it in this form, separated by commas. So don't forget that comma thing. All right. Part E. We're getting down to the last couple questions here. So part E, how often does the line y equals 2 intersect the graph? Now, first thing is you need to know what type of line this is, right? Y equals 2. Y equals any number should be a horizontal line, right? Intersecting the y-axis at 2. So it's basically asking how many times does this line intersect the graph, right? So you have 1, 2, 3, 4. 4 times. Okay, so F, for some reason, happens to be, F and G happen to be the most complicated questions so far. So bear with me as I basically explain this. So I want you to look at part A and see how we answered that question, and then part F and think about what that's asking you. Okay, so part A, right, just as a refresher, part A is saying, when I give you the x value of 0, what's my y value? And so you said 4. When I give you the x value of 3 pi over 2, what's my y value? And we got 0, right? So on and so forth. This question is saying, what values of x is f of x equal to 4? Okay, so basically, let me write it like this. I'm giving you a y value, right? I'm telling you f of x or y is 4. I want you to tell me which x corresponds to me having a y value of 4. And in this case, there's several different ones of them. So here's what I'm going to do. Look at my graph, find out all the points that have a y value of 4. So here's a y value of 4 here, y value of 4 here, y value of 4 here. The question is asking me to give you all of those x values. So there's 3 of them, right? There's one at 0, there's one at 2 pi, and there's one at 4 pi, right? And just so we're clear, look, you could double check this. This is just saying that you agree that f of 0 is equal to 4. You agree that f of 2 pi is also equal to 4, and f of 4 pi is also equal to 4 from our curve. That's what it's asking. For what values of x is f of x equal to 4? Right? So they give you the y value, they want the x, right? So it's reversed. Okay, hopefully that wasn't too bad. All right, so G, I think there's only a couple more questions here. Okay, so for G, it wants to know for which values of x is f of x greater than 0? Okay, if it helps, remember this f of x is just the same thing as a y, right? We're just giving you more information when we say f of x. So I'm telling you right now that I want to know for which value of x is y greater than 0, right? Here's another way of viewing this. When I say f of x is greater than 0 or y is greater than 0, would you agree that every single point on this curve that's greater than 0 would just be above the x-axis? Okay, let me say that one more time. I know that you guys are still taking this online, so it's a little intense. But so put that Hot Pocket down for a second, take a sip of that soda, and listen to what I have to say real quick. So for what values of x is f of x greater than 0? So meaning when is y greater than 0? So that's just asking you, when is the graph above the x-axis? Because all of these points, right, I'm writing in red here, all of these points have y values greater than 0 because anything below the x-axis has negative y values, right? So here's how I want you to interpret this. Anytime you see f of x is greater than 0 and it's asking for which x values, they want to know when is the graph above the x-axis. Okay, and now there's going to be intervals where that happens. So here's what I want you to notice, right? I'm going to do this in blue. Let me erase these red marks up here. Okay, so it's above the x-axis from 0 to pi over 2. Now notice though, at pi over 2, it touches the x-axis, but I just want to know when it's above it. So we're gonna say it like this. It happens from 0 to pi over 2, and actually at 0 we get a bracket, because at 0, is it above the x-axis? Definitely. But pi over 2, it's at the x-axis, so we don't include that. And then it's also above the x-axis from this x value here, which is actually 3 pi over 2, to this x value of 5 pi over 2. So then we can say also from 3 pi over 2 to 5 pi over 2. Notice I don't include either one of those values either, because they hit the x-axis there, and I just want to know when it is strictly above the x-axis. Okay, and then I think it's above it one more time. From this x value here, which was 7 pi over 2, to this x value here, which is 4 pi. Now, at 4 pi, it is above the x-axis, so you're going to watch me include that value. So 7 pi over 2 to 4 pi, and then include 4 pi, because at 4 pi, it is above the x-axis. Okay, and that's the end of example number 2, I believe. So let me zoom out, wait a couple seconds, and make sure you guys have that down. Okay, thankfully 2.2 isn't that long, so we have one more example in example 2.2. So example number 3. So consider the function. The question is asking, is the point 1 comma 1/2 on the graph of f? So look at what A is asking you to do. It's just asking you, when you plug in 1, do you get 1/2? So we can check this, right? So f of 1, right? Well, you plug in 1 for all the x's, you would get 1 over 2. So you'd get f of 1 is equal to 1/2, right? Which corresponds to, I am substituting 1 as my input, and my output is 1/2. So of course, the answer is yes, that point is on the graph of f. For now part B, for x equaling 2, what is f of x? What is the coordinate point on the graph of f of x? So all they want you to do, it sounds funny the way they're wording it, but they're just asking you to plug in 2 for the f function. They should have said find f of 2. That's what they want. So if you plug in 2 for all the x values, you get 2 over 3, and then it wants it in a coordinate pair. So they're saying, they want you to recognize this notation. They're saying, you're saying f of 2 is 2/3. Okay, well, if f of 2 is 2/3, what is the coordinate point? The coordinate point is you plugged in 2, and your y value was 2/3, right? So we kind of talked about that already in 2.1, which is making this a lot easier of an adjustment, hopefully. Okay, now be careful with part C. Part C says if f of x is equal to 2, what is x? And what are these coordinate points on the graph? So notice, right, I'm going to explain this 2 different ways, right? So this is another one to look out for. Part B, you're good with part B because they're telling you, here's x, plug it in, find the y value. This time they flipped the script on you. They gave you what f of x is, or they gave you the y value, and they're asking you to find x, right? Now, sidebar real quick. If I had given you y is equal to 3x plus 7, let's say, and I said find x when y is 5, you'd have no problem viewing the problem like this and solving. That's exactly what's going on over here. They're just not using y anymore. They're using f of x, right? So just notice that if they say if f of x is equal to 2, what's x? They're saying f of x, and I'm going to be dramatic because we can highlight this, f of x is 2, right? So I'm going to take the original function, and I'm going to plug in the whole f of x is 2. So basically I'm putting 2 is equal to the original function x over x plus 1. So notice I'm substituting in 2 for this f of x term and just solving. Okay, so I'm going to multiply both sides by x plus 1. So these would divide out here. Be careful here, I have to multiply. So I have 2x plus 2 equals x. Subtract 2x, you get negative x. So x is equal to negative 2. So you found x is equal to negative 2. But what are the coordinates? Well, your x is negative 2. What's your y? That's what this guy is, right? So I'll say that again. You just found an x value of negative 2. Well, what's the y value that corresponds to that? That's what they gave you. They told you y is 2. So you basically went backwards again, right? I'm gonna put the notation they used, right? They told you f of x was 2, and they wanted you to find the x, right? And then you found that to be -2, and that's the coordinate pair. Okay, now this is again a refresher from the last section. They want you to find the domain of f. Well, the domain of f is going to be all real numbers except for when the denominator is 0. So hopefully we can do this fast now, or you agree with me here. You would say that it's x such that x cannot be, guess it, all right, -1. You don't know how awkward that is to say it to no one, by the way. So if that's the set builder notation, if it's in interval notation, you're including everything besides -1. So it'd be from -infinity to -1, and then from -1 to infinity, right? So I'm just giving you both sets of answers, right? Again, the homework goes back and forth and as far as which one to use. Personally, I think you should get used to interval notation more than anything else. Okay, the last two questions. Find the x-intercepts and what are those points, and then find the y-intercepts if there are any. Okay, so here we go. Remember, to find x-intercepts, we normally say let y be 0, right? We used to say, or not. Okay, we'd say let y be 0 normally, right? We have to change this now to say we don't have y, we have to say let f of x be 0, right? To find the x-intercepts. So again, we were given f of x is equal to x over x plus 1. So we set the entire thing equal to 0. 0 is equal to x over x plus 1. If you multiply both sides by x plus 1, you just get 0 is equal to x. So, of course, your only coordinate is 0, 0. Now, I told you this already, that if you have the origin as an x-intercept, you're also going to have that as your y-intercept. Okay, so it's going to be no surprise over here that when you plug in 0, so here you're going to let x be 0. We don't have to change any of that. 0 over 1, 0, no surprise there that the origin also pops up as a y-intercept because the origin hits both the x-axis and the y-axis. Okay, so that's the end of that. The main idea was, again, knowing that how to look at graphs and define functions. I'll scroll back down. I know that was really fast. How to define functions just by looking at the graphs, or to determine whether or not a graph is a function by using the vertical line test. And then we just had a quick refresher of all the stuff that we did in the last two sections. And basically some of the questions like E and F come from chapter 1.